This is a short demonstration using BedRock ULTRA with the VNClagoon suite of applications. The BedRock ULTRA security layer is transparent to the VNClagoon applications you see running here on an AWS OpenShift cluster. In this demonstration, we'll take a cluster running VNClagoon and introduce new BedRock worker nodes to secure the container workloads. We can see that all applications are synced to the GitOps repository and are running properly. Here, we can access the VNC directory landing page with an admin user already logged in. These applications are blind to the compute nodes they are scheduled to run on and will function the same when running on BedRock nodes. In order to add BedRock to a cluster, 3 resources will need to be created. Beforehand, users should set up access to their BedRock AMI and OS container image provided by BedRock. The first OpenShift resource is the machine config pool. This will direct OpenShift to apply machine configs to BedRock labeled nodes. We can see the MCP come online after a few moments. Next, we'll create a machine config to be applied to the BedRock worker node. This config references a custom container image. Your OpenShift cluster should have access to this BedRock provided image when adding in BedRock nodes. When creating this MC, allow your cluster to create a new rendered config file for the BedRock config pool. This is a collection of all configs being applied to the BedRock class of nodes. Finally, we'll need to create a machine set that will control the provisioning of our AWS instances. When creating this machine set, ensure that the OpenShift configurations, the machine set names, roles, and types, are labeled as BedRock. We also need to ensure that the provider specifications for AWS are also set. The AMI ID should point to the BedRock AMI, and the instance type should be a bare metal instance, in this case, C5 metal. We'll create the machine set and then allow OpenShift to provision all of the necessary resources. This could take up to 20 minutes to introduce these machines to the cluster. We can see the progress of the machines and then the nodes in the web console. When these nodes are finally displaying the ready status in the OpenShift console, we know that they've been added to the cluster. We can access the BedRock Debug UMX console to see some of the console and log outputs from the AWS Serial Access Connection page. We can also see that with the new compute resources, VNClagoon is still running just as expected. Now, let's see BedRock ULTRA in action by using Soteria. Soteria is a purpose-built Linux kernel module, which contains open attack vectors for testing security features. With Soteria, we can see examples of the low-level protections BedRock provides when enforcing its policies. First, we prepare the tester on a BedRock node set to permissive. Security policy infractions will be logged here, but not blocked. We can see that the failed tests appear in the Soteria container, and the infractions are logged in the brass console. In a traditional OS architecture, there is no privilege level higher than the kernel's. This means if the kernel changes something, it can also revert those changes. BedRock ULTRA creates a layer with a higher privilege level than even the kernel. This layer is not modifiable by the kernel or any other applications running on the OS. Let's see this protection in action as we run Soteria against a node with BedRock blocking attacks in enforcing mode. We'll see the Soteria attacks blocked in the container terminal and the logs recording these actions in the brass console. One example of the kernel's inability to protect itself is memory access permissions. The kernel tries to protect itself by setting its own code as non-writable. However, an attacker that's gained some foothold in the kernel via vulnerability can simply make that memory writable again. However, if there exists a higher privilege level that is enforcing memory access permissions, then that change cannot be overwritten by a malicious kernel operation. In this demonstration, we've seen the installation of BedRock into an OpenShift cluster and the protection mechanisms in action with a Soteria tester.